Hello, I'm Paul Whitkay, founder and CEO of the Alliance of Chief Executives. I am very excited to welcome you to the third of what will be an ongoing series of Alliance Visionary Leaders Roundtables, in which we are inviting leaders from around the world to come together to discuss how innovative leaders are transforming major industries and ecosystems in ways that are profoundly changing the way we live and work. First, I'd like to thank Rayad Fazani for bringing together this esteemed panel of leaders in the energy industry. It's a world-class experts and executives and leaders. As you'll see, each of our panelists brings incredible experience to the conversation today. Whether they're involved with global enterprises, early stage disruptive companies, or clean technologies, they are all innovating how energy is produced, distributed, and stored with an objective to build more sustainable energy systems for the future. Today's roundtable may focus on energy and the environment, but whether we are personally involved in the energy industry or not, it applies to all of us. As we've seen in our last two Visionary Leader Roundtables, new technology and innovations in areas such as semiconductors, high-speed computing and communications, IoT sensors, artificial intelligence and machine learning, robotics and automation, nanotechnology and material sciences have all enabled innovative leaders to transform every aspect of our lives. I believe disruptive ideas typically come from outside our own industries and happen when we are able to meet leaders in other industries who force us to think differently. So often we're able to borrow some of these ideas to transform our own industries. Now it's my privilege to introduce you to Rayad Fazani, who will moderate our roundtable today. I met Rayad in 2010 when he was a senior executive for BP and had recently been the CEO of BP Chemicals business, a $10 billion global business with 6,000 employees, and had come to the San Francisco Bay Area to be the CEO of BP Solar and Wind. BP Solar and Wind consists of 3,000 employees, and they developed and operated solar and wind farms in the United States, Europe, India, and China. His plan was to spin it out and go IPO, but 2008 turned out to be a bad year to go public. So when BP asked Rayad to return to London, he and his family decided to stay in the Bay Area, and he transformed himself into an entrepreneur. Rayad launched Regenerate Power to develop large-scale renewable energy projects and is actively involved with a number of exciting new clean tech ventures. And I'm proud to say he is also a member of our Alliance team of directors. Rayad, take it away.
Thank you very much, Paul. Welcome, everybody, and thank you for joining us. This is going to be a very exciting and informative panel. I've tried my best to pick the best of the best, and now set the expectations for them to wow you with their insights and their achievements and their thoughts about the future of energy. What I'd like to do first is to have them introduce themselves to you. I'm going to do that in first name alphabetical order. So that means Atul, you get to start. 60 seconds, please, up to 60 seconds introduction for the audience.
Yeah, thank you, Rayad, and thank you for inviting me. I'm Atul Arya. I'm Chief Energy Strategist at the S&P Global. I have a 30-plus year career in the oil and gas industry and then renewables industry. And these days I work on energy transition, climate change, and the large company strategies for energy transition.
Thank you. And Gary next.
My thanks also to the organizers for inviting me. My name is Gary Dirks. I'm the Senior Director of the Global Futures Laboratory, and I'm the Director of the Lightworks Initiative at Arizona State University. In addition to that, I'm the Chairman of Carbon Collect, a startup company that is commercializing technology that was developed by Klaus Lochner, who's also on this panel, at Arizona State University. I'm very pleased to say that I'm joined by Rayad Fazani on the board of that company, which frankly is going very well. I've been at Arizona State University since 2009, and prior to that I was with British Petroleum for 34 years.
Terrific, thank you, Gary. Ian.
Hi, everybody. Ian Conn. I'm Senior Advisor on the energy transition and climate change. I do that for a number of people, the largest of which is Blackstone. And I'm also a Senior Director on the board of BT, the telco in the UK. My executive career was 34 years in energy, 29 with BP, latterly as on the board and chief executive of the downstream part of the company. And for 5 years after that, I was chief executive of Centrica PLC, which is an energy services and solutions company based out of the UK. Nice to meet you all.
Thank you, Ian. And then Dr. Klaus Lackner.
Hello, I'm Klaus Lackner. According to Newsweek, I'm a disruptor right next to Elon Musk because I have been pushing the idea of managing carbon as a waste management and as a closing the carbon cycle idea now for nearly 30 years. I am the founder of the Center for Negative Carbon Emissions at Arizona State University. Before that, I was the director of the Lenfest Center at Columbia University and the Ewing Brazel Professor. And before that, I spent 17 years in the desert at Los Alamos to develop energy issues and generally a wide range of things Los Alamos is involved in. So I have a background in the science and technology issues, which we have to address.
Terrific. Thank you, Klaus. Next is Laurence.
Yes, hi. Thank you for inviting me. Laurence Mullier. I now have a portfolio, so I'm on the board of several companies, one of which is Siemens Energy, where I'm also chair of the audit committee. Siemens is engaged in the energy transition, but I'm also the chair of Voltalia, which is a listed company in Paris engaged in renewables only power production, and the chair at Globalec, which is another power producer focused on Africa, and having more of a mix of thermal and renewables. So we try to square that. In the past, I spent a few years in banking and 16 years at BP, after which I was backed by a private equity firm to build a power producer. So that's me.
Thank you, Laurence. And then finally, last but no means least, Rafi.
Rafi Garabedian. I'm a serial founder, mostly around the semiconductor industry related technologies for most of my career. I'm an electrical engineer by training. I spent 13 years at First Solar, the more recent 8 of which as the chief technology officer there. That's where I learned all things solar, energy, and energy transition. Happy to be here.
Terrific, and great to have all of you, and thank you for devoting your time to today's roundtable. So next I'd like to then go around the table and ask you to outline for us in 3 minutes or so your vision for the future of energy and the environment, and how you see it changing, major changes and opportunities and threats. I'd like to start with Ian.
You caught me on the hop there. I thought you were going to be doing the usual alphabetical. So nice to see everybody again. What I'm going to do is just give a little bit of context that I think is relevant to this conversation, and then talk a little bit about how I see things panning out. So contextually, the energy transition, we all know, is well underway, but we are also on the wrong path. We're heading for about 2.5 degrees C temperature rise against a goal of 1.5 to 2. The progress is slow. The UN FCCC COP process, I think of it as the slowest common denominator. There are 2 numbers that I'd like you to remember. Total global greenhouse gases are 49 billion tons a year, of which energy related is 33. Energy is not all of it, in other words, the difference being agriculture and land use. Why are we off track? I'm going to put it to you, 5 big issues are not being addressed sufficiently, whose materiality is not understood. These require material inroads in the next 5 years. The first is unabated coal in Asia, principally China and India, but that's 10 billion tons out of 49, or 10 out of 33. Hard to abate industrial sectors, that's 7.8 billion tons. I'm thinking of cement, smelting, etc. Thirdly, heating and cooling, 8.7 billion tons. So that when you take hard to abate sectors, which is also about heating, process heat, heating and cooling is an amazing 50% of energy-related greenhouse gases. The fourth issue is the cost of this transition and who's going to pay for it. It's going to cost about between $1 to $3 trillion a year to 2050, and that probably represents a 20 to 30% uplift in the cost of energy. Is it worth it? Almost certainly, but we don't have the mechanisms yet to be able to deploy it. And finally, the fifth one is, unfortunately, as you see today, the geopolitical realities, and especially energy security, which is a rate limiter, such as China, dependent on coal, the EU and natural gas and Russia playing out now, US relations with Russia, Iran and China, and relations between Iran and Saudi. So all of those are relevant bits of context. So what about the future? Firstly, the pathway to net zero must be with hydrocarbons, not without them. It is going to be like two tectonic plates rubbing against each other, and we are going to have earthquakes periodically. The pathways for light transport and power generation are reasonably clear, which is why we've been pursuing them. Light transport's been about efficiency, hybridization and biofuels, and then electrification. Electrification, not hydrogen, for light transport. Power generation is about efficiency, natural gas and biomass replacing coal, nuclear where it's acceptable, and renewables as the main drive. On the five big issues, unabated coal in Asia is going to see fuel substitution and scale projects for hydrogen, blue hydrogen with CCS. Hard to abate sectors will see blue and green hydrogen hubs clearly demonstrated at scale in the next 5 years. Heating and cooling cannot be transported. So we're going to see massive growth in solutions at the edge of the system, near where heat and cool are required. This will mean energy efficiency, combined heat and power units that are already happening, fuel substitution, biomass, hydrogen injected into natural gas, heat pumps, including hybrid high temperature heat pumps, distributed services and solutions. And on who pays and how, we're going to see implementation platforms of materiality emerging, and funding vehicles will emerge to channel the significant flows chasing the transition. International financing mechanisms will be put in place, including to help finance the decarbonization of coal in China. A controversial view I have is that the West is going to have to partly pay for the decarbonization of coal in China. Returns will initially be bid down until decarbonization capacity enables investor choice, which we may start to see in 5 years. And finally, geopolitics and energy security will be a major brake on progress. And unfortunately, the current situation in Ukraine won't help. Thank you.
Terrific. Thank you, Ian. Great summary. I appreciate that. So I'd like to move to Laurence next and your vision for the future.
Sure. I won't, thank you, Rayad. I won't repeat the context. I think that was very well explained by Ian, so I won't talk about that. My vision is there's going to be a lot of renewables on the grid, and I'm going to focus very much on the power sector. So I could see in 5 years' time, 30 to 50% of the power to the grid becoming renewable, with Europe being ahead of the US and emerging markets being behind, significantly behind. I could see a lot more storage on the grid, with a majority of batteries and some hydrogen, mostly gray or blue. I could see EVs starting to be used as storage and representing over the 50% of new vehicle sales. I could see AI and digital helping a smart grid come to the fore to optimize and utilize the grid and have the lowest possible cost, avoiding grid interruption and providing services to the grid. I think there will be some standards emerging for ESG credentials, and I suspect, we'll end up with one for the US and one for Europe. But for me, the biggest change is going to be in business models. I think the growing importance of merchant power for renewables means that banks will start financing merchant power much more than they are doing today. I think that capacity payments will be widely used as the marginal kilowatt hour the cost will tend to zero. And as we have more and more renewables on the grid, we're going to have to use capacity payments rather than just rely on the marginal cost of the kilowatt hour to fix the price of power. I think the oil and gas companies are going to be using the major cash flows they're getting from their oil and gas projects and their project management know-how to develop huge floating wind farms and a lot of carbon capture projects and some hydrogen projects. And they're going to be the big movers in that area. I think the price of oil is going to be, next 5 years in the $70 to $120 per barrel, and gas significant, is going to remain high and tight over the next 5 years. I think there will be the price of carbon in Europe will be above $100 per ton. And I hope that other regions are going to develop other mechanisms of that sort, which will, again, change the business models of a lot of companies. And I diverge a little bit from Ian in that I think green hydrogen will still be expensive. It will be starting to be used more, maybe in thermal plants as part of the mix, but I think it's going to be just the beginning because it's still expensive. So that's where I'm diverging a little bit from Ian. That's it for me.
Terrific. Thank you, Laurence. So I'd like to move to Klaus next.
Yes, I think, let me set a slightly different background, which probably has a longer time scale associated with it. In the climate area, people sort of like to talk about tipping points. I see a number of big tipping points coming along. The first one is that the climate itself is tipping. I think it is now very clear that climate hurts, warming hurts. And that has been debated for a long time, but the latest IPCC report sort of has pushed the world past that point. The second part of that is, of course, that it's also now more or less publicly accepted that that is true. So the politics of it all moves in that direction too. So I think the climate issue has forced us to deal with the problem. I think we are not really ready for it. I suggest that in the long term, we at the minimum have to think about this as a waste management problem. For the last 200 years, we simply extracted carbon from the ground and thought that burning it to get the energy out is perfectly fine. And the resulting CO2 can be safely put into the atmosphere. The same issues we had with sewage and municipal garbage are now catching up with CO2. And I think the rules will change towards a rule, and this will not happen in 5 years, but over the longer time. It will change to that if you dig up a ton of carbon, you better show me another ton of carbon which has been put away. And so for that, we need technologies which can balance all of this out. In parallel to all of that, I think the energy landscape is changing also. When I was a student, people talked about solar and wind, and it was 100 times too expensive and nothing much really happened. But over the last 50 years or so, it actually has managed to get 100 times cheaper. And this is a fantastic result. But the net result is right now that the raw primary energy from a photovoltaic panel is already cheaper than the raw primary energy in fossil carbon, with the exception of dirty coal, which is very hard to clean up and therefore we can safely set aside. So my point is we are entering the transition where it actually starts making sense to not think of PV or wind as producing electricity for the grid, but providing raw energy in form of electricity with which something useful has to be done. So I would argue we are actually not as far away from getting very green hydrogen out of that, because we really have to learn how to make electrolyzers a lot cheaper than they are today, because it's actually by now the capital cost of the equipment which sits idle, which we cannot afford. So this is where I think I see the tipping points, and I see that they come together in a perfect storm. It's very rare that the incumbent cannot play. In this case, the incumbent fossil fuel is really hampered by the climate change issue, and the new guy is coming on the block and can change things dramatically. So I see as a vision for the longer term that we have energy coming in cheaper and cheaper, that we deal with the capacity issue by simply taking the energy we don't currently need and convert it into hydrogen. And don't kid yourself, if you have hydrogen and you have CO2, we have since the 1920s technologies which convert that into methanol, diesel, jet fuel, you name it. So we can run a world on hydrocarbons if we can collect the CO2 back from the atmosphere, which, by the way, we have to learn no matter what, because we have reached an overshoot. Up till now, the discussion was, how do we put on the brakes and come to a stop in carbon dioxide emissions? I think the world has passed this point, and we now will have to figure out how to get some carbon back. You heard that we are roughly putting 40 gigatons of CO2 into the atmosphere. Every year, I'm leaving out the other greenhouse gases for this discussion, but order of magnitude, it's 40 gigatons a year. That drives CO2 up 2.5 ppm a year. If we want to fix the problem, we are going to talk about 100 ppm reduction in some form or another. And yes, I could be wrong. It could be 50, but it could also be 200. So if we want to get back that amount, we need to, for 40 years, pull 40 gigatons a year back. That alone is well beyond biological systems, and we will need technologies like Carbon Collect is building, like Climeworks is building, to actually pull CO2 back and safely dispose of it. In parallel to this, once we have that done, we can also use this as feeding into a market. So what I see for the next 5 years is the transition. Right now, you could say that Climeworks put a marker in at about $500 a ton of CO2. That is not affordable in the long run, but it's about 10 times too much. At $50 a ton of CO2, the world can live with it. We are in the $1 trillion range. And if you do mass production and you look at the learning curves or the cost reduction curves, because it's really not learning, in mass produced equipment, you can see that the cost comes down roughly a factor 20% every time you double, which is equivalent to saying every time you go 1,000-fold, you have reduced the cost 10-fold. Now, there's an irreducible cost at the bottom. We don't know what it is. And I would argue Carbon Collect is minimizing that irreducible cost, and therefore is in a very strong position. But what you need to figure out is how to grow 1,000-fold. Now, right now, the world in air capture is 1,000 tons a year, a few kilotons a year. By the time we have a few megatons, which is that factor 1,000, we still haven't gotten to the point where we are seriously impacting the climate. We are on the size of a scale of CO2 markets for making fizzy drinks and filling fire extinguishers. That in the US is a 7 megaton market a year. So if you get to that point, you either know that this technology is unusual and refuses to come down the cost curve, or, which is a very, very important lesson to learn, because then we need to get from plan B to plan C, or you will have managed to drive the cost up. And I think this next 5 years will see this transition. This is an incipient technology right now, which doesn't really know what it will cost. And there's a lot of changes which will have to happen. By the end of these 5 years, we will know whether this technology is a great winner. And if it succeeds to get the cost into the $100 a ton mark, by that time, we will know that the world has a solution to the problem, and we can actually keep our hydrocarbons in the system and fly airplanes and take the CO2 back later.
Thank you, Klaus. Terrific. So I'd like to go to Rafi next.
Klaus really nailed it in his preamble, and I think my comments are going to be somewhat superfluous, but I'll make them anyway.
Please.
So, look, I spent a I spent over 13 years in solar. My job was to develop technology and to scale that technology in high volume manufacturing, module technology in particular. In those 13 years at First Solar, we deployed nearly 20 gigawatts, I think, of product via both project development activities, primarily in North America, and module sales, direct module sales to other developers globally. When I started in PV, it really was a niche technology. You know, I like to say in air quotes, Birkenstocks and tree huggers, not pejoratively, but as characteristic of kind of the off-grid hobbyist character of PV back in those years in the early 2000s. Today, as you all know, it's taken its place as one of the fastest growing energy resources globally, not only because it's clean, but as Klaus alluded to, because it's dirt cheap. And that's a critical factor. I saw LCOE of solar decline from something like $200 a megawatt hour to something like $20 a megawatt hour, and as low as $10 a megawatt hour in many places in the world. At the same time, wind has followed a similar cost trajectory through, both technologies through innovation and scale. We now have ready, scalable access to the cheapest, cleanest electricity in human history. This is a remarkable asset that we have the ability to build. But there's a rub, right? And Klaus, you mentioned that the capacity factor of this energy is low. That's the rub. We need power when the sun isn't shining and the wind isn't blowing. And the mantra of electrify everything, it's a convenient soundbite. It gets a lot of traction in the press. It's easy to say and it's easy to hear, but it takes far too much for granted. And if pursued carelessly, it actually makes our energy transition and emissions problems worse. On a grid powered by renewables, electrifying energy consumers that operate at high utilization rates, asynchronously to the renewables themselves, increases cost of the grid and increases emissions disproportionately by requiring extremely expensive battery storage and or fast ramping fossil resources. That's just a fact. Batteries aren't going to get cheap enough to fill the void and get us to 100% clean grid. We need other alternatives. So predicting the future, that's a fool's errand, but I'll try it anyway. The guidance for this comment was to think about the next 5 years, not the next 50 years. In the next 5 years, we are going to, as a society, internalize these challenges. We're going to recognize that shoving more renewables onto a grid and trying to soak up that power at low capacity factor is only a piece of the problems, piece of the solution. We have to solve the rest of it. As we begin down this journey in earnest towards decarbonization, I think we have to consider seriously the prospect of converting power to molecules. We will start this process with renewable hydrogen production via electrolysis. It is my belief and the mission of my company to perform this conversion at extremely low cost with very cost-effective equipment so that the resulting hydrogen is effectively at parity with fossil resources. Ultimately, with that capability, we can utilize hydrogen as a chemical and energetic feedstock for the production of many, many higher order molecules. Again, as repeating Klaus, right? We have the technology, we know how to do this, we've known how to do it for decades. These are the molecules that underpin industrial civilization. Everything from the food we eat, the fertilizer for that food, to the extremely long duration storage of energy in molecular form. These are fundamental to human society, and we can't just wave our hands and say, electrify everything. We have to actually think it through. The path to electrifying everything ultimately goes through molecules.
Excellent, thank you. I'd like to go to Gary next and then Atul.
Thank you, Rayad. We've already heard some very compelling visions, and so I'm not going to attempt to repeat any of what we've heard, but rather maybe try to fill in just a little bit around the edges. And I'm going to couch my remarks more in terms of an energy journey than an energy transition. And there's a number of reasons why I'm going to do that. First, transition implies that we can identify a beginning state and an end state, and then something happens to get you from one to the other. And of course, the challenge with that is if you look around the world, everybody is in a different beginning state. Part of the reason we're having this discussion is there's not a lot of agreement about what the end state should look like. And what's really more important is exactly how are we planning to get from where we are to where we think we want to get to next. Now, I'm emphasizing that for several reasons as well. To begin with, there's been decades now of commitments made by governments and increasingly by businesses and NGOs, a whole range of organizations, on what they're going to do about dealing with the future of energy, particularly in the context of climate change. But if you look at the next level of granularity behind those commitments, there's very little in terms of implementable plans. And this is what we really need to be thinking about, is getting beyond the commitments to what those implementable plans look like. We've heard a lot about technology here and the importance of developing new technologies and business plans as well. What is the economic backdrop against which this journey is going to take place? Really important stuff. But I would argue that it's more the social side that we really have to focus on. And what I mean by that is, at least using my language, and you'll find many, many different ways of framing what I'm about to say, every step of the way, wherever you are looking in the journey, this journey needs to be just and equitable. This journey needs to get us to net zero carbon. Energy needs to be reliable, and energy needs to be affordable. All four, at all times, every step on this journey. Now, the challenge with that is it's not good enough that you agree on a framework of that type that I've just described. The order in which you put things matter enormously. You have a very different pathway into the future if you put affordability first and equity last. You get another one if you put carbon first and you put reliability last. Now, it's my belief that we're going to see another shift in this journey from where we have traditionally been with the energy system. And that is, a lot of the really critical decisions are going to be made very locally. That's not to say that the international agreements don't matter. That's not to say that national policies don't matter. They matter critically. But a lot of the really nitty-gritty decisions are going to be made very locally. In populations from a few tens of millions down to literally small communities. And part of the reason for that is, as we've heard from other speakers, the new energy system is going to be far more dependent on renewable energy, and that is far more distributed. And there are many more choices that people can make, and they're going to want to make them locally. So, what does the next 5 years look like? Well, I insist on being optimistic because I find pessimism so depressing. So, sticking with sort of my normal optimistic self, I believe we're going to see an emergence now of much more effort at what can we really implement. And we're going to see a much greater focus on what do you need to do to get these sub-national groups of people geared up so they can have a conversation about, do we put equity and justice first, or is this all about affordability? Which, by the way, is precisely the debate that's going on in my state. How do we go about doing this? I think that requires then that we have all of the work that's been implied by the others with respect to let's get a better suite of technologies that are available to us. And we've had some great suggestions about that. Let's be clear about how we're going to finance all this stuff and what kind of business models are workable. But at the same time, we need to get the local city council bucked up so they understand the decisions that are meant to be taken. So that's my vision for where we're headed. I remain insistent that we will get our heads around this before the middle of the century, but it's going to be a close run thing.
Thank you, Gary. Excellent. All right, that's all. I've given you the toughest task of all, which is
That's great. Well,
your
thank
vision
you.
at the end of this. Yes, thank you.
Thank you, Rayad, and thank you, everybody. So I'm going to try and not repeat what all the excellent contributions. So I'm going to put two pieces of context and then talk about the future. So the first important piece of context is that there is a lot of talk about energy transition, but actually we are not. You know, one can say we are always in transition, but the reality is if we think about transition as changing our fuel mix, in that metric, we went from 83% of hydrocarbons 30 years back to 80% now. We want to go from 80% to zero or near zero, net zero, in the next 30 years. So that's a monumental task by any measure. The second challenge we have is that the other metric I use is emissions. So of course, in 2020, the greenhouse gas emissions went down, but we are back up, and actually the emissions are about to exceed all-time high. Global emissions. Now, there are countries and regions which have done better, but globally, greenhouse gas emissions continue to go up. And as all the climate experts on this call will know, that the emissions are what we call the bathtub effect. That even if you stop emitting, the emissions are not going to drain until you take the tap out. That's where things like carbon removal become hugely important. Of course, there are natural processes, which will take some emissions out through land and sea and trees and so on. But the sad reality is that if you go to the NOAA site, you can see the monthly greenhouse gas concentrations, and they continue to go up. So a lot of talk, tough challenge, not much to show for everything we have done. So how do we tackle that? I think Ian and Lawrence both mentioned sort of the sectoral approach. I think the sectoral approach has to be the basis for it. And we can talk more about how we get there, but things like hydrogen, for hard to decarbonize sectors, is going to be more than just electricity. We need something more. We need heat and not power, and heat sources are different. That's why we use natural gas, which is such an important fuel for transition. So that's one important thing. The second thing I would say is that money, which was also mentioned. This is a kind of big philosophical question, that next dollar of energy, removing emissions, should they go to Germany or should they go to India, right? And you would argue maybe they go to both. Then we have to have more dollars. The $100 billion commitment was made in Paris, was never met, and that should really be the floor and not the ceiling. I think, Ian, you mentioned several $1 trillion. We need a lot of money. The report which came out yesterday, I think the numbers are even higher now. So the money, as I say, money talks, and we need a lot more money. And a lot of that money needs to go to places like India and China and South Africa. I think one of the great things which happened in Glasgow, which hardly anybody mentions, is that a number of countries, well, OECD in general, committed to, $23 billion, sorry, $8.5 billion to South Africa to reduce its emissions, or decarbonize its coal fleet by 2030. If you take the same math and apply it to India, that's about $40 billion just to decarbonize India's coal industry. So they're talking some, really big numbers, but that's the money thing which needs to happen. There are a couple of other things I'll add. One is that, if you go to solar, and I was in solar before you, Rayad, and before Rafi, when it was really kind of a cottage industry. And solar is terrific. I'm a huge fan of solar. I think we need to focus a lot more on supply chains for solar. They need to be diversified. They need to be expanded. The scale of growth we need for solar and other technologies is monumental in terms of just building that capacity. So how do we do that? How do we make it more international? And it's not just about China. It's just we need more supply chains. The two other things to mention. One is that I think the oil and gas industry, Ian, you mentioned, oil and gas industry has to be part of the solution. This is the industry which knows how to deal with big stuff, complexity, putting steel in the ground, building relationships, creating value chains. And they have to be part of the solutions, though I would say as a former member of that industry has not done a really good job communicating their vision and being, so it's been kind of, one day we are very engaged, another day we are opposing methane emissions, right? So it's kind of one of those stop and start approaches which really needs to change, and it is changing. I don't want to be too critical, but they have to be part of the solution, and everybody has to come together. The last thing I would say is that really the best thing in my view which has happened is that since I'm probably starting my career around the same time as Gary, at least, when we started our career, there was nothing called digital. I don't think I even had a laptop or a computer desktop. Well, I had one for doing reservoir simulation, but they were like a big thing. Now everything we're doing is digital. We're going to do carbon capture, it's digital. We're going to do hydrogen, it has a digital component. So digital is everywhere. And I think how we integrate digital to energy, which is happening in power sector quite well, but in other sectors has to be a big opportunity. So how do we bring that together could be another. And by the way, these things can happen in the next 5 years. The last thing I'll say, Rayad, is that, and everybody, is that scale really matters. Anything below a gigaton, not interesting, right? So what can we get to the gigaton scale of carbon removal in the next 5 years? I think there are a few choices. The one which I think really needs to scale is CCS. I have worked on CCS for now 25 years and have almost nothing to show for it, unfortunately. 40 million tons of carbon being captured today. So if you want to get to even to gigaton, that's 25 factor. So I think we need to get on with it. And and there's a lot of interesting work going on, but it is going to be quite challenging. By the way, the hubs, I think somebody mentioned the hubs idea for CCS. It's going to be the way to start, because if we can put something out in the ocean away from populations, that's a good way to perfect the technology before we really scale it up. So I'll stop there and get into the discussion here. Thank you, Rayad, and everybody.
Terrific. Wow. So that was awesome. Thank you very much to all of you for amazing and, well, in many ways consistent, but in many ways quite different visions of the future in terms of timing and pace. I picked up 5 kind of key areas of summary, if you like, or focus. Obviously, policy, local and more global and regional. Technology, customer and consumer behavior changes, financing, and business models seem to be kind of the 5 things that came up conceptually. I want to get going with our discussion or dialogue. So I'd like to first ask, what did you hear that you thought was low priority? And what did you hear that you feel is high priority in our discussion so far, in those buckets, if you like?
I don't know that I heard anything people say that I would describe as low priority. That, in fact, encapsulates the nature of the problem that we're dealing with. And that is, it is multidimensional. And you ignore dimensions at your risk. So I felt like the speakers were all very good about focusing on things that are going to matter. Now, in terms of high priority, and this again reflects my bias a little bit, but I think it's really critical, as I said in my remarks, to get to implementable plans. And that then begs the question of how do all of these different perspectives integrate? In spite of the fact that I described this as a journey as opposed to a transition, we have to be really, really conscious that there is no yellow brick road into the future. And we do need to remind ourselves that yellow brick road led to a really funky wizard who wasn't of much help in the end. And so we're going to have to be able to integrate all of the perspectives that we heard while maintaining a very broad front of possibility and not closing down too quickly on avenues that we can pursue. And this has been mentioned a few times, but I think it's particularly important with respect to incumbents. There is among the social scientists, some social scientists, a real sense that we need to put a stake in the heart of the incumbents, that they were at least in part responsible for getting us here and they shouldn't have a role in the future. And that's precisely the kind of closing off that I think would be very dangerous. And I'll maybe just leave it there and let others comment.
I'd like to support what you just said, Gary. And I'm going to try to do so very briefly, but with a comment around solar deployments. So as many of you know, there's far more solar deployed globally in utility scale, grid connected ground mount solar systems than on rooftops. But rooftops get a lot more press because they're in the public eye. As consumers, we see them, we have the opportunity to act through them on our own houses. But in terms of really offsetting carbon emissions and cleaning up the electric system, working through the utilities and through the existing infrastructure and business structures and social structures has been far more effective. And I'll leave that evidence for people to think about.
Terrific. Ian next, and then Klaus.
I just want to, I'm going to ignore your question to some degree, Rayad, but I'm going to just pull a thread out of this that I think Rafi and Klaus were very impactful around, which is this, the obvious scenario, which I think it is obvious, that we're going to end up with cheap intermittent electrons. And we also know that we need to capture some CO2 back from the atmosphere because we've gone past the point of no return. And we also have to produce hydrogen for certain applications, not, in my view, transport, although the jury's a bit out on heavy commercial transport. Light transport, it's just a crazy idea. We do need to store energy because it's intermittent. And the whole notion of actually going via molecules that Rafi was talking about, I do support. And one of the craziest things I've read in the last month, in my view, is the CEO of Airbus going to convert an A380 filled with hydrogen tanks at negative 253 degrees centigrade to demonstrate that an engine can run on hydrogen in an aircraft when actually you can capture CO2, combine it with hydrogen, make synthetic jet fuel or biojet, and you don't need to do that in the first place. So I think the pathways through molecules, leveraging cheap electricity, is one of the big things I take away from the conversation so far.
Terrific, Ian. Thank you. Klaus.
One of the things I like to think about comparison side by side between two things, because it's easier to see which one's better than the other. And so my students, I give a counterfactual. I say people don't really like rooftop solar in the grid because it is upsetting the apple cart because it's so intermittent. So hypothetically, you'll assume for a moment you're not allowed on the grid because you are so disruptive. What would you do? Well, at 1 penny a kilowatt hour or $10 a megawatt hour, which we heard, you could easily make hydrogen. And if you have CO2 at $100 a ton or $50 a ton, even better, you have the ingredients for making a gallon of gasoline at around $1, maybe $1.20. So as a result, it is now a problem of the capital cost of your electrolyzer, and you have to get it down. Once you have made all the same chemicals as before, you can actually retain the infrastructure you have, and I don't think you're all that much more expensive than you are today. Now, was that optimal? Of course it wasn't optimal, right? Some of that electricity should have gone straight in the grid because the grid right now wanted it. Some of it is much better stored in a battery than making a chemical, because if you want to store it for a few hours, I can't beat a battery. If, on the other hand, you want to ship it across the country, it turns out a pipeline with liquid in it is a far better deal than an electric power line. And furthermore, if you want to sit on it for a year, because you have to balance out between summer and winter, or even worse, between a good El Nino year and a bad La Nina year. You end up having to store for a long time, and batteries are simply too capital intensive to make that work. So at the end of the day, you clearly will optimize in this thing, but you started now from a premise where storage is not a problem anymore, and you made it better. Right now, we are in a kind of forcing all the electricity in the grid, which is a natural thing to have done because we started there. And so we have to figure out how to combine these two views and find the middle ground. And I think ultimately we need to do this fast. And this is what I was originally going to say. It's fine to think about all these great new technologies, but if we live in an overshoot world where we have to come back down, you suddenly can say that we have irreversible damage in the decades in between, how far we exceed the baseline, the danger zone, and for how long we do it. That will set the game. So we also should be open to all these other technologies, even though they are maybe not big enough and they can't go, but they can go instantly. So I don't want to get into a debate whether mineral sequestration is better than geological storage, because we should do both. I don't want to get into a debate whether we should do afforestation or not. I am convinced we cannot do it at 40 gigatons a year, but on the other hand, we can do it right now and it's affordable. So let's put everything together and drive things down. And this goes ultimately to Gary's thing. We need the political will and the social structures which make that happen, and we don't have them yet.
Very practical. Thank you for that. Rafi, and then Laurence.
Thank you, Riyad. Klaus, I feel like I need to meet you at some point in person.
Well, we can do that.
So really quickly, some comments were made around the deployment rate, the capacity to deploy renewables. And yes, it's frustratingly slow, but I would comment that capacity has been ramping steadily over the last decade. And so the current rate of deployment is actually far better than the backward-looking penetration would make one believe. The other comment I'd like to make is that the constraint to both solar and wind adoption is not, in my opinion, manufacturing capacity. I agree with the comments around diversity in the supply chain and the need for diversification of that supply chain globally. But having said that, the constraints to solar and wind adoption, in my opinion, are all related to the interconnection to the grid. I do not believe that we are looking at an either-or situation where the electrons, renewable electrons, can be used for one purpose, electrification of light-duty vehicles on the one hand, or the other purpose, conversion to molecules. We can have both at the same time. We can build a lot more windmills than we're building today. And simply put, it's because we don't have the ability to take that resource, intermittent resource, onto the grid effectively and smoothly while maintaining reliability across the world. So what does this all mean? I'm talking to a bunch of CEOs here. CEOs are always thinking about business. This is an amazing opportunity. We've been talking about decarbonization, which is the fundamental underpinning of why we're together and doing all this stuff. But if one can see their way to building equipment, industrial equipment that can operate at extremely low capacity factors on intermittent energy, then one can harness that incredible resource to do useful things. Hydrogen is an example of that. And the comment was made by Klaus that cheap electrolyzers are the key to unlocking hydrogen. Absolutely, completely agree. Electrolyzers have to become extremely inexpensive. Why? Because they're operating at low capacity factor if we're producing green hydrogen, so-called green hydrogen, fossil-free or renewable hydrogen. And that same thought process can apply to other industrial applications. Think chlor-alkali process as an example. Think about aluminum smelting as an example. These typically run at very, very high utilization rates. Why? Because the CapEx is high. This is all food for thought and opportunity for CEOs to think about.
Terrific. Thank you for that angle. And Lance.
I don't think we need to choose at this point in time. But I'm a little bit like Gary on this practical way of what can we actually implement in the next 5 years, 10 years. And even though some of the technologies, I would love for them to be here. But if you look at PV as an example, 40 years to get to the cost we're at, right? So it took 40 years from the first deployments to be economic now. So if we're starting a new technology today, how long will it take for it to be economic? And I'm a big believer in economics rule the day. So if it gets to a low cost, everybody will adopt it. You don't need to do any publicity or anything. Everybody will do it because it's cheap. So, we have some solutions. Let's implement them. That's all the renewables. Let's do them as much as we can. I think the battery is coming down. Maybe not fast enough. Maybe it's still expensive, but it's coming down. So let's do as much as we can on these things. We shouldn't shut out any technology. Just be realistic. It's going to take a long time for the cost to come down. And that, saying I'm counting on this, for example, solar in the atmosphere to solve all my problems. I'll think again, because I think it's going to take a long time. So I'm more on the, being pragmatic about it. The other thing is on the government and local policy. Maybe all of us and the CEOs that are on this call should get more involved locally, because even though we can't tell the governments to change the price of CO2, maybe we can influence local communities a lot more than we are doing it today. And I agree that a lot of this is distributed, and what are we doing to change the mindset around my backyard? What are we doing to explain it? Are we doing enough? That's the question I have.
Excellent. Gary, Ian, and then Atul.
Lauren has sort of picked up on what I wanted to develop, so I'm going to shorten what I had to say. And Rafi, I think, was taking us in the right direction when he was saying it's CEOs on this call. And I think CEOs really now need to be thinking very hard about how do they facilitate getting the right quality conversations so good decisions can be made. And I'm going to use my state here, recognizing that it's not particularly exemplary of any place on the planet. Arizona has a very unique character. Although one of the things I learned in working for BP is no matter where you go, everybody is quite clear that they're different or they're unique or we are special. So perhaps we are ordinary in being unique. The problem we have here is a very broken discourse. Policymakers are hit by a myriad of great ideas coming from all directions on what it is we should be doing. In the meantime, Rafi is pointing out how important grid connection is. We need a lot more transmission in this state. We're getting by okay because we're shutting down coal plants. But at some point in time, we need transmission. There is no quality conversation around that. People aren't prepared to engage with our corporation commissioners in a broad-based discussion. People aren't prepared to engage with our city councils in a broad-based discussion. There is no facility in the state that pulls together people of serious expertise and have them talk it through. What are the limitations of the solution that you're suggesting? What are the strengths of it? How certain can we be? I think CEOs have a unique role to play in this, but they have to be willing to go into a room with people who aren't going to agree with them. And some of them could be a little bit feisty in the way in which they don't agree. We have to work our way through that. There is no shortcut. in being able to do this. So that's where I think a lot of attention needs to be in the next 5 years.
Thank you, Gary. And yes, I recognize that role that CEOs can sometimes play, because everybody wants business to be successful ultimately for their own mutual benefit. Ian.
Thanks, Rayad. And just building actually on a couple of the last comments, the energy system for a very long time has been production out in its mindset. Whether that's hydrocarbons or electricity generation, we've created it and taken it to the customer, and the customer has had very little choice. Whether they can have gasoline or diesel, you can play tunes a little bit on that. You can have electricity coming out of the socket in your wall, as long as it's from your default local utility company. Now that's changing, of course, but that's been the history. And yet the reality is that, as I said, 50% of energy-related greenhouse gases are related to heating and cooling, which by definition has to be at the edge of the system. And someone else mentioned the importance of local and the convening power of cities, and the fact that in 50 years, 75% of the world's population will be in cities in Asia. This all points to localized solutions. And in my last job at Centrica, we were developing services and solutions for consumers as well as businesses. We had 12,000 people in the UK who go around helping people install equipment in their homes. So we started diversifying that offering to optimization of energy in the home, to lower carbon energy in the home, and very importantly, just less energy in the home. And some of the new technologies being developed for businesses to substitute and reduce the carbon footprint are becoming really economic at local scale. So I would encourage all the CEOs to be thinking about, what could I actually apply with the technology that already exists in order to change the way I optimize the energy system and in my factory or locality, and be aware that there are solutions providers starting to be able to offer that at sensible economics.
Atul.
Yeah, thank you. So I'm just going to pick up on a few things which have been said and just offer additional thoughts. One is, I think there's this important issue, since we've talked so much about technology, is the issue of learning curve. And more recent work, and there is a very good paper, if you have not seen, from Oxford around the learning curves, and they are accelerating. So I think there is an opportunity to be faster. I take the point, Rafi, about the history of solar versus the future of solar, right? Different pace of implementation, but there was a massive learning curve built in. There is a massive learning curve built into it. I think the question is, which technology can leverage that? And here is a word of caution in my perspective. See, many of the technologies we are enamored by, like myself, enamored by solar, are electronics-based technologies. Learning curve for process-based technologies are a lot slower. And again, there's massive amount of work by my good friend Václav Smil, who I know people don't like anymore, but he has highlighted these issues. I'll just read you one number. Steam turbine efficiency has improved by 1.5% in the last 100 years every year. Semiconductor efficiency is improved by 35% per year. And that's what Václav calls Moore's curse, because that's what everybody wants to believe in. So I think we need to kind of think harder about the technology. That's my one important point. The second thing, I do want to go back to sort of this just transition and the issues around how do we deal with that? I think it's the most critical issue in my view, because 2 billion people, yet to get access to energy. And I heard an amazing statistics that the amount of energy consumed by the lowest 3 billion people, lowest consumers in the world, is 1/12 of the average energy consumed by an American citizen. So all of us, so most of us. So that's a huge disparity. And I think we have to think. I was just speaking with the CEO of ESCOM, because he's coming to our conference next week, and he pointed out Eskom in South Africa emits 25% of emission for all of the continent of Africa. Think about that. And the reason, because they're a very big coal producer. So if they're going to shut down their coal plants, there are massive equity issues, massive redeployment of people issues. These are not easy things to say about, is coal out or coal down? That's easy word, soundbite, but these are really very challenging issues. And I think the CEOs need to think about that as they think about the future. And that's why I think more money, go back to my original point, more money has to go to those countries. And I think we should have, I recommend you all, the Alliance of CEOs, have a conversation with all non-OECD speakers to get their perspective on the same questions we're talking with us.
No doubt, and thank you for bringing that voice. And that is it was one of the themes that came out of the questions from the audience. So I'm going to go to Klaus and then maybe add a couple more questions from our audience. Go ahead, Klaus.
Well, let me make a point about the hardware issues comparing photovoltaics and wind with large-scale things like steam turbines. You are right. I, some years ago, got into this, though, from a different aspect, that I would like to give you a counterexample. The humble car engine you can think of as a power plant. It's $10 a kilowatt. There's nobody else who can do that. Your coal-fired power plant today in the US is $1,500 a kilowatt. A nuclear power plant is $5,000 to $8,000 a kilowatt, and even solar is bragging that they are below $1,000 a kilowatt. So that $10 a kilowatt is the result of mass production. One of my former students in his PhD analyzed this, and one of the things we learned, small mass-produced things can learn fast. And I think what we found as a rate limitation, and this is a big change today, that in the past, this ultimately leads to personnel costs. If you were to replace a power plant with 10,000 car engines, which is roughly the size of a power plant, and you would end up with 10,000 operators, you couldn't pay the operators. That is why historically we had no choice, but in every industry we had to scale up. The car is an exception because I don't want to buy a 50,000 seater, I want to buy a 5-seater. And so I had no choice, and I couldn't really make it work if the capital cost is high because I can't park the car. So the bottom line is mass production of small things can work, but it requires computers and automation to prevent the escalation in personnel cost. If every machine needs its own operator, we can't do that. If you build air capture devices like the mechanical tree carbon collect builds, which collects 80 kilograms a day, you can't have a person pay attention to it. As a matter of fact, even if the system goes into an off state, a failure mode, 90% of those have to be taken care of by computer automation. I think the big revolution we are seeing today is that we have that computational capacity to do that. And with that, we are seeing another revolution in the industries, that numbering up rather than scaling up is suddenly an option. And that changes that game dramatically. And we should pay attention to that.
Terrific. Thank you. I have a question from the audience. How do we best match the reduction in fossil fuels with the introduction of alternative energy sources? What happens if we shut down fossil fuel plants too quickly? I'd like to ask Gary to kick us off on that.
Well, in my opinion, all sorts of bad things happen if you shut them down too quickly. And in fact, one of the things I argue here at the university that doesn't make me entirely popular is putting pressure on production is exactly the wrong thing to do. If we want to pick a path in this journey that is going to kill the momentum towards decarbonization, create artificially high prices for energy, and watch what happens to the population. So I think we need to be especially thoughtful about exactly this. How do we phase out one as the other is able to function reliably and affordably? And this gets back to my point about reliable, affordable, net zero carbon, and just and equitable. We must maintain reliability. And the best way to do that is to recognize that sometimes we may need to put up with new fast ramp gas generators for a while because hydrogen isn't quite ready to go yet and batteries are too expensive. So I think the questioners put their finger on a critical, if not the critical problem that many of the communities that are on this journey are going to have to deal with.
Laurence?
Yeah, I'd like to add that in a lot of parts of the world, and Atul mentioned India, but Africa is in the same place. If you've got indigenous gas, you've got no baseload power, and you've got millions of people who have never had power, how can you actually say, we're not going to give you power? I mean, I think it's just not acceptable when the Western world has been emitting all this carbon, and you know that promotes having the power, having power for those countries actually promotes economic development and allows people to reach a standard of living. I don't think we can say we shouldn't build new gas plants, for example. So you know, we not only is it a question of shutting down, but I think we need to continue to build in a bunch of places. And if China, instead of building coal plants, started building gas plants, for example, that would be a win. But you know, there's still a lot of places that don't even have power, and it's not a question of shutting down. It's a question of building both renewables and the gas plants.
Great point. Thank you, Ian.
I was just going to come in on the question. It's a great question. I mean, I think for not very long, but for too long, we've been in a period of green is good, fossils bad. That is the most ludicrous place to have been, but it's where society's got its head at the moment. As I said earlier, that this transition is going to be, whatever it means, it's going to be like tectonic plates, and there are going to be moments where you get a real shock. And in the IEA's net zero scenario, I think they forecast that we're still going to be using 24 million barrels of oil a day in 2050. And I think from memory, the forecast is that we will have reduced the amount of fossil fuel we're using by about 2/3, and we can still get to net zero. So we've got to figure out how to do this transition with hydrocarbons. And I think Klaus and Rafi also demonstrated that there are other pathways that incorporate hydrocarbons from electrons to hydrocarbons. And so this societal naivety, which is understandable because everyone would rather have green than not green, but no one's really been courageous enough to explain it so it sticks. And I put the blame, I think Gary mentioned it, politicians are not very capable in this area, nor are they trained to be, and they tend to be switched out every 5 years, which is a major issue. So we fail to learn from each other, and the materiality of some of what is required that all of my eminent colleagues have described means that society's got to get that, and they currently don't get it.
Thank you, Ian. A great point. Klaus, before I get you back in, I just want to add another question, which is interesting. Do we fully understand the environmental impacts of clean energy and other energies, such as water requirements for clean hydrogen, increased mining for solar, wind, and batteries? Is this a legitimate concern for the industry?
Let Rafi go on that, because I was going in an entirely different direction.
Thank you, Klaus. It's of course a legitimate concern, but like everything in life, it's an alternative. We have to weigh the alternative costs and benefits of paths we take and choices we make. So there's no free lunch, right? You maybe have high blood pressure. You want to take medication to lower your high blood pressure, but you have to consider the risks of that medication. Energy is energy. It always is going to have environmental impacts one way or the other. So let's get over the kind of debate over whether clean is truly clean and completely clean And we can always poke holes at technologies and their environmental impacts. Let's think kind of pragmatically about the relative outcomes, and then weigh our choices from there. That'd be my comment.
Thanks. And Klaus, do you still want to come back in?
Sure. I was going to make the point that ultimately this is economics. I agree on that point, and I give you an observation which was not environmentally nice. That's fracking. But nobody saw it coming. But when it was cheaper than the competition, it took over. And in the US, it pushed out coal. Right? So I would argue if we manage to get all of this to a lower price, it will happen by itself. On the other hand, you need regulations on the side of the CO2. And I come back to think of this as a waste management problem. And I don't mind personally, and I get in trouble for that, if people want to use fossil fuels, as long as they clean up after themselves. If the rule is for a ton of carbon coming out of the ground, you have to show me a certificate of sequestration that another ton has been truly permanently put away, I'm fine with that. And I think the world should be fine with it because the climate problem has been solved. I think from a practical perspective, if you really have to take 100 ppm back, we are talking about a requirement for 1,500 gigatons of storage. Now, most likely they exist, but it's a long ways from saying there's a resource capacity, resource availability to having proven reserves. And I would predict if that is our trajectory, storage will stay expensive, which in turn means that the renewable energies which don't have to put things away will have an inherent advantage. And let the markets sort it out. But in the end, you cannot keep dumping CO2 in the atmosphere, just like we can't put sewage into the city streets, or for that matter, into the rivers. And we learned it the hard way. And today I wouldn't buy a house without a proper attachment to a sewer system. I would not, and think about the difference to mitigation. If I leave my garbage on my front neighbor, they won't take it as my neighbor's front yard. They won't take it as an acceptable thing that I told them it's 10% less than last year. Right? We have to get to the point where you are not allowed to dump. And we are currently allowed to dump into the atmosphere, and it's perfectly fine even to do that if you take an equal amount back out. But you've got to figure out how to close that cycle. And it doesn't need air capture for everything, but it needs it for the last 10%.
Thank you for that. Gary.
As to the speaker's question about the supply chain and potential environmental issues, I think this is something, and Rafi and Lawrence both said this, I want to elaborate on it. We have to take extremely serious. And there's a couple of reasons why I say that. One is we know that from mistakes of the past, that looking into the full depth of supply chains is something that's critically important to do. And the other is, as we move forward in this energy journey, it's going to be very important, or it's going to be very easy for populations to be disadvantaged through benign neglect. Lawrence has already mentioned the impact on coal communities when you shut down the coal plants. These are devastating impacts on many communities. Some parts of the world are doing a really good job of addressing those really hard problems. Much of the world isn't. The same is true now for sourcing into these new technologies. We've all seen images of places in the world where it just isn't being done well and populations are being marginalized. We have an opportunity now with the world that we're trying to create where that doesn't happen. We are clear about who's responsible when you shut down a coal plant. One of the problems I have in my state, nobody wants to be responsible for it. We are clear if we're going to mine lithium in Chile, who's responsible for what's happening in the Atacama Desert. These are things that the CEOs, again, can be very important in ensuring that happens by just simply asking the question, how does this work? How does the whole thing actually work?
Thank you, Gary. there are a number of questions about the future of the electric grid or electric grid power. Um, and maybe I'll just pick one out and have you guys have a noodle with it. How do you envision the electric power grid in 2030, 2040 and beyond?
Well, I think it has to be more connected. It has to be, I think it will have a lot more renewables on it, but we need to have mechanisms and system to make it more to make it reliable, because inherently intermittent power destabilizes the grid, right? So we need to have a way to compensate for that. So it's either storage at some of the knots in the grid system at some of the central points, or it's more interconnection, which several speakers alluded to previously, that it's important to actually increase the interconnectivity. I can't remember if it was Rafi or Gary who mentioned that, but very critical to have more interconnection to support the grid, and some grid services that oftentimes can be done by the storage that you can put at central points in the grid system. But that's essential, and we need to have that in mind, and not just the producers of power, but also the grid operators. I know they do have that in mind, but it has to be planned 10 years out, because it takes a long time. And at the moment, that part, the grid and the transmission system, the growth rate in Europe, for example, is 15%. So it's a high growth rate, and people are realizing they need to do something about it, but it's not high enough, in my view.
Great. Thank you. Gary?
I think, again, this is a really excellent question. And my response would be, number one, everyone has access to a grid of some description, whether that means it's a microgrid in a remote location or it's a continentally connected macro grid. People are connected to it. The second thing I think we're going to see with the grid is it's going to be much, much, much smarter than anything we've got right now. That it will have the ability to detect right down at your household level how power is being consumed. If there happens to be solar panels, what are you doing with those solar panels? How does the charging of your electric vehicle, assuming that's what you've got, how does that impact on the global demand of the grid? All of these capabilities, I think, are going to need to be in place by 2035. And I'm cautiously optimistic we may actually see things like vehicle to grid charging. Certainly, again, I'm overemphasizing Arizona, but it is desperately important that people charge their vehicles during the day here, because we have massive amounts of sunlight in the middle of the day, so much that it causes us trouble, and we got to do something with it. And charging up vehicles, driving them home, letting them give some power back to the grid, one possibility.
Thank you, Gary. And in the interest of time, I've got one last question to ask, and I'll let you, Atul, have a first go at it. What criteria attributes will define the winners and losers in this transition?
You're switching gears here. I think a lot of that has been discussed. My feeling is one of the things which is going to happen is a lot more partnerships of different kinds, because in the old days, big companies could solve problems because they were good at, it was a monolithic business in some ways. Now it's going to be very different. And one of the leading indicators is, look at how many big companies have venture businesses in there, or investing in startups, because they don't want to miss that opportunity. So that's the one kind of a partnership, trying to bring new technology. I think partnership with different sectors. So we, again, in our CERAWeek event, we're going to have the CEO of Ford talking with the CEO of PG&E. The relationship between which used to be an oil company with auto, needs to be more with the power utilities and autos. in the future. So I think that's going to be another partnership. And the other one, which has also been mentioned, is the public-private. I think, for example, in the US, one of the hidden gems we have is the national labs. And I think they need to come out more and engage with the industry to help, bring new science, innovation they are doing to scale. And some of them are doing it like NREL, for example, and ETL, but that's going to be another. So multiple dimensions of partnerships, very different from what they used to be in the past.
Terrific.
I would like to thank you, Rayad, for bringing together such an incredible panel. I personally, I just like hanging around really, really smart people who think differently and make me think at a higher level. And you have outdone yourself. These are amazing people. It's the best, well-rounded, high-level conversation on the challenges we face in the energy transition. And I think Garo is the one who said how multidimensional, how incredibly complex this whole challenge is. And it's an existential problem that will require all of us, particularly our leaders, to be informed and exhibit leadership in not only in our own organizations, but within our communities. So I really thank all of our panelists, Atul, Ian, Gary, Rafi, Klaus, Laurence, for coming here, sharing your visions, and really having an enjoyable conversation at a very high level with each other. So it is exactly what we envision to enable our audience to just get a better perspective from a wide range of viewpoints and parts of the industry sector. So thank you very much.